that week. Thanks, Eric. So, Victor, you saw us use one of your products there, the latest 7 Series FPGA from Xilinx in that last demonstration. I'm pretty confident our customers are going to do amazing things with that technology. Tell us a little bit more about 7 Series kind of under the hood.
Sure. The 7 Series family of FPGAs is based on the state-of-the-art 28-nanometer process. The small geometries allowed us to lower the power consumption while increasing the logic density, the signal processing performance, and the I/O bandwidth to achieve a dramatic increase in FPGA performance.
Yeah, it's very cool technology. And I know that you, Xilinx and Arm, are working together on some new technology. Why don't you tell us a little bit about that?
Yeah, that's right, Eric. So, we introduced a whole new product category with the Zynq family of all programmable SoCs that's based on the Arm architecture. Zynq integrates a really powerful dual Arm Cortex-A9 processor subsystem and SoC together with our high-performance and power-efficient 7 Series FPGAs. So Zynq really packs a ton of capability in a really small form factor, and thanks to the invaluable feedback that National Instruments has provided us as one of our preeminent Lighthouse customers, it's really the ideal engine for the LabVIEW Real architecture and a host of other applications.
Yeah, we have been very excited about the Zynq SoC and NI. As you said, it's sort of a realization of the LabVIEW Real architecture on a single chip. And our hardware and software engineers have been working very closely with Xilinx since you had the first emulation boards available for Zynq, and today we're very proud to announce the first product based on Zynq from National Instruments, the new Compact Rio 9068 software design controller. Got one right here to show off. Now, our goal is to design this product around Zynq to be the most open and flexible Compact Rio ever. We actually have a machine over there on the right side of the stage from one of our early access customers where they've incorporated the 9068 already. I've invited Priya Ramachandran from our hardware R&D group up to show us the machine and the impact of the new controller. Priya?
This machine was designed and developed by Master Machinery. Master Machinery is one of the leading manufacturers of semiconductor process equipment, and they're based in Taiwan. This here is a vision-guided motion pick-and-place machine used in the packaging of semiconductor components.
So, why don't we start it up?
Of course. Here we go. The machine is equipped with Basler cameras and Kollmorgen EtherCAT motor drives with the Compact Rio 9068 at the heart of the control system. NI Vision is used to process the images to locate the components, and NI Soft Motion is used to move the tables synchronously with the actuator to enable the actuator to accurately pick and place the components. I'm running the machine at slower speed. Let me now show you production speeds. As you can see, the machine is performing the same tasks with the same accuracy, but now at speeds that can keep up with the throughput requirements of process equipment.
So, Priya, can you quantify the performance improvement that Master Machinery saw with the new Compact Rio?
Absolutely. Master Machinery has told us that machines with the same functionality and flexibility as this one can output about 1,000 to 2,000 units per hour. They had previously designed this machine with the Compact Rio 9074, and with that, they were able to achieve 14,000 units per hour. With the new Compact Rio 9068, they were able to increase their throughput even further to 20,000 units per hour. So that's a 10x performance improvement over competition.
Cool. 10x machine. And clearly for an application that's serving a semiconductor process industry, that throughput is very important for their customers. So guys, you can see an example of your technology in action and helping to solve these customer challenges. Now, Tom, for ARM, I think when most people think of ARM, they think of probably their cell phone. Tell us a little bit about ARM and embedded.
Well, firstly, congratulations on an amazing event and a fantastic new product. Most people think about ARM and our processor technology powering the mobile revolution that we're all involved with and carrying it in your pocket, as you said. The ARM partnership last year shipped about 9 million chips into the marketplace. Now, what probably most people don't know is a little over 2 billion of those devices went into the embedded processing area, and it actually is our fastest growing market today. We and the ARM partnership have spent a lot of time over the last several years of ensuring that our processor cores were capable of the high reliability, high temperature, and low power requirements to power this next generation of intelligent systems.
Yeah, you guys are right in the middle of the programmable world that I talked about earlier. So in the new compact Rio, we're using a dual-core Cortex A9 processor. Tell us a little bit about that processor family.
Yeah, Victor and I were talking about that earlier. You couldn't have taken a product, or they couldn't have chosen a product that was right in the sweet spot of technology. We've licensed this core to about 60 customers worldwide, of which Xilinx is a key partner of that. It powers about a third of the cellular phones that are in shipment into the market this year. And I think it is testimony to sort of the technology sweet spot of performance, power, and area that our semiconductor partners desire. So it is a core that is now spanning multiple applications from the highest end servers. We actually have customers putting server products into the market with it. Clearly it was designed for mobile phones. It's in consumer devices like digital television sets, as well as automobiles. So it really spans the market. What's really interesting to us, though, is this new activity that we've started with Victor and the team in creating a whole new class of products.
Yeah, so what's the Zynq SoC kind of mean from ARM's perspective?
Yeah, well, truly innovative technology of integrating CPU technology with Fabric and leveraging the ARM ecosystem to do that. And it opens up all new markets for us, which we're really excited about. Xilinx services a vast majority of markets and applications we traditionally haven't reached. And it opens up a whole new world of solving heterogeneous compute. So from a hardware technology, extremely exciting and really cutting edge. I think what's really exciting to this audience is the combination of this technology plus your software tools and LabVIEW programming models really opens up heterogeneous compute technology to a much broader group of engineering that don't really need to understand CPU technology and just can program using their domain expertise. So really exciting.
Yeah, absolutely. And so, Victor, besides the amazing product that we just launched, where else are you seeing success with Zynq?
Yeah, we're just as Tom said, we're really in a broad variety of applications. Embedded design teams are implementing Zynq in systems like automotive driver assist systems, situational awareness in aerospace and defense applications, and also broadcast cameras with real-time image and video processing and analytics. So really a very broad range of applications, communications infrastructure, and of course LabVIEW, which is awesome.
Now most of those you cited, they sound like traditional high-volume embedded designs, probably traditional design teams, right?
Yeah, that's absolutely right, and I think that's why we're so excited to be working with National Instruments. The ARM technology combined with Xilinx technology, powered by